Yes, welcome back to second part of chapter number 4. Uh, we finished before this up to example 4.8. Next topic is force of friction. Friction is a force that opposes the relative motion between the two surfaces or two systems in contact. Right? The force of friction, you see, whenever you have two surfaces in contact. For example, if you have this surface, okay, and you have, for example, you can have any, for example, you have iron on the wood or the glass on the glass. Even if you have glass on glass, these two surfaces, you see, you may think that it's very smooth surface between the two, but if you use the magnifying glass, mukabbar, you will find that the two surfaces in contact, they are tightly packed and there are some rough surfaces between the two. Actually, this roughness between the two surfaces is causing the force, is creating the force of friction. So force of friction arises due to roughness between the two surfaces. Okay, the force of friction is proportional to the normal force. If you are on the horizontal surface, for example, like this one, and this is an object having the mass m, its weight mg downward, and the reaction force on the upward direction, in the upward direction. So this force of friction is proportional to the normal force. If you put some more weight on it, uh, the force of friction will increase. Of course, you can think about, you see, is it easier to push a chair across the floor empty with someone, or with someone in it? For example, if you have an empty chair, and if you push it, and then if some person is sitting on it and you again try to push it, you will find it a bit difficult when a person is sitting on it. Why? Because mg is increasing. You are putting some more mass of that person, for example, on the chair, and you see, normal force is equal to mass multiplied by the acceleration due to gravity. So force of friction will be uh, increasing. All right, you see, whenever you have parked your car in the parking lot, it's not moving. Why? Because there is a force of friction between the tires and the road. We call, when the object is not moving, the car is not moving, we call it the static friction. Static means at rest, not moving. So we have the static force of friction, F sub S, right? And when you start the car starts moving, you're moving on the road, again you have the force of friction, but this time the kinetic force of friction. Kinetic means in motion. So when the object starts moving, still you have force of friction, but we call it kinetic force of friction. So this is F sub S, static force of friction, and this is F sub K, K for kinetic, mean motion, moving. Right. We have the direction of frictional force is always opposite to the direction of motion. For example, if you are moving on the right side, for example, this is the direction of motion, direction of the force of friction will be opposite direction. You see, the normal force we have seen in the beginning of this chapter, that whenever you are applying force, we use capital F, but the force of friction we use small f. Okay, and subscript S with this for static force of friction, and F sub K for kinetic force of friction when object is moving, kinetic, and when it is at rest, static force of friction. Right. You see, we have good friction and bad friction in life. For example, if you see, I'm writing on this drafting pad, so I am able to write on it due to force of friction between my pen and this drafting tab. Now, if there is no friction, I'll not be able to write on it. Similarly, you are driving your car on the road due to force of friction. If there is no force of friction, you will not be able to drive your car and you will be facing some accident. You might have seen in the rainy season, there are more and more accidents on the road. Why? Because there is less friction, and especially once you have taken a wrong turn, you know, uh, it is going out of the control. So force of friction, good and bad. This is good friction. And bad friction, once when you have moving parts in some machine due to wear and tear. For example, if you talk about your brakes and the brake pads, after some time you have to go to the mechanic to change the brake pads, because uh, due to running of one part of the machine on the other, you have to change it. For example, similarly, if you have some in mechanical manufacturing plant, you have some lathe machines and all these, you might have seen that you are using a coolant or you know, the mobile oil or other grease, just so that to reduce the friction, force of friction. Okay, all right. So uh, keep in mind that when the object starts moving, the force of friction, we call it kinetic, and that is less than the static force of friction when it is not moving. Now you see, static force of friction. Static force of friction acts to keep the object from moving. It tries to stop the object, right? So if you increase the force, static force of friction increases. If you decrease, it will decrease. So this is the rule for static force of friction is equal to mu s. This is Greek letter mu sub s, which is coefficient of static friction, and n is the normal force. When you are on the horizontal surface, if m is the mass, so this is mg, and this is the normal force, right? So in this case, n is equal to mg. But keep in mind, when you have tilted axis, this will not be the case, okay? Because theta is involved, and we have already checked what happens when you have the tilted axis, inclined plane. We'll see in coming one or two examples also, right? So this is called the coefficient of static friction, right? And this, in from this equation you can write mu sub s is equal to static force of friction or normal force. What is the unit for this coefficient of static friction? Force in Newton, and normal force, which is equal to mg in this case, again Newton. So no unit for mu sub s. Now kinetic force of friction acts when the object is in motion. So we have this rule again, the coefficient of kinetic friction is equal to F sub K over the normal force. Again, no unit, right? For coefficient of friction. You see, this is a graph between the force applied and the force of friction. This side you have force of friction, right? You see, this is along this side you have force applied. You keep on applying the force, and force of friction increases. You reach the maximum. You see, this is maximum Fs, static force of friction, maximum up to here, this one, right? Now after that object starts moving, and this one is called the kinetic force of friction, which is less than this one. So kinetic force of friction is less than static force of friction, right? Okay, or you can say force of static friction is more than kinetic. So kinetic is less, static force of friction is greater. Okay, now this is the maximum. Okay, so this is the point here. So this region is called static, from here up to here, and from here up to next, this is kinetic region. So this is how we get a graph. All right, we're going to solve this example first, which is 4.12, a block on a ramp. Suppose a block with a mass of 22.5 kg is resting on a ramp. So this is the ramp, it is resting, and keep in mind that this is the weight mg, always downward. This is theta, so this is also theta. I have told you in the last lecture that, just for remembering, the side which is in front of this theta is having mg, is having sine theta involved, right? So this is mg downward, this is theta, side in front of this is sine theta component, okay, which is force mg sine theta. And since this is parallel to this, so I write it here, this side tilted axis. So this is plus x, this is minus x. So this side is force of friction, which is F sub s. So it is resting on it, so not moving. So this is static force of friction. You see, this is the surface, perpendicular on it, this is the normal reaction, okay, and exactly opposite to this, this is mg cosine theta. Again, this is mg, the side in front of this theta is having sine component, so this is mg sine theta, and again I put it here, the parallel, and the third one which is left is mg cosine theta, right? So right, so in this case you have to find out, so this is your 0.350 is static force, it's coefficient of static friction, which is 0.350. This is your mass, and you have to find out the maximum angle the ramp make with the horizontal before the block starts. So you need to find out what? Theta. Alright, so when it is resting, and I told you you have to go for sum of the forces equal to 0 because it is resting, and I told you also in the last lecture, whenever one force is making some angle theta, like in this case mg, which is weight, is making some angle theta, so you have to go for x and y components separately. Okay, first of all we go with sum of the forces along x-axis is equal to 0. You see, first of all I have tilted axis, so if I go for example like x negative and x positive, you have this force along positive axis. No doubt these are the tilted axis, so mg sine theta positive, and along x-axis you have force of friction. This side you have this one, okay, this is along x-axis. So the positive force mg sine theta minus F sub S, which is equal to 0. Now if I write mg sine theta is equal to F sub S, and mg sine theta, you see we have just finished that static force of friction is equal to mu s times the normal force. Let me call it equation number 1, right? Then I have, the second case, sum of the forces along y-axis equal 0. Y-axis forces, this is plus y, which is the normal force, and negative y-axis you have mg cosine theta. Okay, so you should write here minus mg cosine theta equals 0. If I take this on the other side, it will become positive, right? So n is equal to mg cosine theta. So let me call it number 2 equation. You see, what is this? This is n. What is its value? mg cosine theta. I would take this value of n over here, and I would write mu s, static coefficient of friction, n this value mg cosine theta. This is equal to mg sine theta. M goes with this m, g goes with this g, and I take this cosine theta on the left side down, so it becomes sine over cosine theta is equal to mu sub s. Sine over cosine is tan. Tangent theta is equal to mu s. This will give you theta is equal to tan inverse mu s. Tan inverse mu s. Mu s how much? This much. 0.350. Okay, 0.350. So you get 19.3 bigger. This is your answer. Okay, next. The hockey puck in figure stuck by, this is a hockey puck, and we stuck it by a hockey, is given an initial speed v sub I, this 20, on a frozen pond. The puck remains on the ice and slides this much. So this is delta x. Down steadily until it comes to rest. Vi is 1.2 times 10 raised to 2 meter, and finally comes to rest mean final velocity 0. Determine the coefficient of kinetic friction. So you have to find out mu sub k. Now you see, the key idea in this is sum of the force. You see, it's now moving, not at rest, is equal to m a. Right now the motion is along x-axis, right? So you have here The sum of the forces, you see, this is the motion, okay, around to the right side, okay. It's going by itself on the ice. Only force acting is along the negative x-axis, which is F sub k. There is no other force. So this is your F sub k is equal to m multiplied by a, Newton's second law of motion. And since this is the force of friction, it's always negative. Negative means it is opposite to the direction of motion. So this is plus axis. This is along the negative x direction, so I take it negative, of course. Right. Force of friction is always in a direction opposite to the motion. So negative sign indicates that it is in the opposite direction. Now, we have seen that F sub k is equal to mu sub k, kinetic coefficient of friction, multiplied by the normal. When you are on the horizontal surface, this n is equal to mg. So n is equal to mg. So I would write instead of this n, mg, right, minus mu sub k. M goes with m, and you would get, I take this minus to the other side, okay. Okay, so mu k is equal to a over g minus, okay. Now g 9.8, a is unknown. So first we will find out a. Once you find out a, you will use acceleration a value here. So we have this equation of motion, third equation of motion, which says this one. Now this finally is 0, you see here. Vi delta x, how much? 1.2 times 10 raised to power 2. Okay, so if you take this on the other side, it will become minus 20 square. So you would get finally a, okay, 2a 1.20 times 10 raised to power 2 is equal to minus 20 square. So finally you would get a is equal to minus 1.67. You would use this value over here, and you would get 9.8. You would get 0.170, right? No unit, because it's coefficient of friction, kinetic, no unit, we already discussed. So this is that was the last example, and this is end of the chapter, and we will do chapter number 6 next, and then tutorial. So thank you very much, and